talking about this whole reproducible workflow and adjacent things and more therein. You have seen this slide a couple of times now, indicating that for us, when you do reproducible neuroimaging, everything is important to get from data, ideas, hypothesis to results and beyond. With everything we do, needs to be shared in a way that is reproducible, and its whole execution should also be, of course, reproducible. And this is only sufficient if we do it right. The cool thing is that Repronym is actually part of a larger ecosystem supporting these things. So it's not only Repronym, but there's Repronym and Repronym, like friends thereof, and things Repronym also utilizes in its way to make things more open, reproducible, including standardization, data management, fair news, community engagement and support, as well as trying to make it inclusive. So starting with project creation and data acquisition, starting with that process. We already heard, I think it was Chris telling us it, there are huge problems when you want to share data, especially under GDPR in Europe. So there's this thing called the Open Brain Consent that's actually intended to make this easier for everyone involved, ethics committees, but also especially the researchers that work with that. However, when in 2018, GDPR came along, this wasn't really a thing anymore because we are not allowed to share any personal data, especially not outside Europe and these things. So we opened an open discussion issue on GitHub, starting to outline these issues. And in 2019, get together at OHPM, working on it. In the same year, actually went to Brussels to talk with more people around the European Union there. And then 2 years later, we have an article out in Human Brain Mapping that describes this brain consent, specifically also including GDPR information and showing you example submissions for ethics committees that entail information of how you can share your data, even under GDPR, even MRI data. You have data user agreements in there. We translated it in over 10 different languages, and it's really a nice all over thing from over 45 people all over the world, which is super cool. And I can say I did it on my end in Germany a bit, and every ethics thing I submitted with that went through. So I can actually share data under GDPR, even though it's neuroimaging data. So I highly recommend it to check that out if that is of interest to you. Then going into data conversion, we already learned there's a lot of tools out there. Things I want to highlight here are UDConf and Reproin, because with UDConf, which in itself is a Docker container itself, again, of course, you can easily, with only a few lines of code, convert your DICOM images that you have in there into bits, confirmed data sets with metadata included, file naming patterns, directory structures, all there for you. If you want to take it further, this in basically make use of UDConf, combining it with DataLab and describing how you should set up your MR scanner acquisition protocols so that you get automatically shareable version control bits data set right from the scanner, which is obviously really what we want. So in these two things, we can make use of the Open Brain Consent form and the datasets standardization as already used containers. Now, going into analysis and results, this is something to be already outlined, is that when you do analysis, there's quite a bit of variability in there, and depending what you use and how you do things, basically everything can change from only slight differences to something being significant or not. With the NOBS project, really nicely showing that, and currently there's the EEG manual labs project going on that will do the same thing for EEG analysis. So what can we do about it? Going back to having data and analysis being same or identical, and if we have data standardization, so we know what to expect from a data set, the files they're in, how they're named, how they're specified, what's in there, we can actually create analysis pipelines and processing workflow that run automatically on these things, because we can use this information, put it together with containerized environments, and create this thing called bits apps. With the idea basically being you create an analysis processing pipeline, pack it into a software container, a virtualized computing environment that expects bits data sets. You can share it and people can run it no matter where, their laptop, on HPCs, can use these things openly. And because it's bits data sets, if everything is bits conform, they will run. And when you go to the website, you can see that there is quite a few apps out there available for people to use. And it ranges from free server, there's also SPM in there if you want to, and further. I just want to show you a few of them so you get an idea of what's possible. This is the Bits app, and I'm sorry for, it's like very selfish here, but it's a Bits app I created. It's called a Bitsynym, and it's actually building upon sharing data under GDPR and these things, because this is a Bits app that will automatically pseudonymize your entire data set. So it will deface your image files, and it will also adapt the metadata information, removing potentially sensitive information from there, providing also some evaluation, showing you how good the defacing worked, and if there's any sort of information in your data that might be problematic for data sharing. There's this cool thing called MRIQC that allows you to automatically run quality control on bits data sets, both for anatomical and functional images. And if you do that, you basically get a wide range. This is just an example report here of image quality matrix, easily showing you if there's something wrong with your image, which we see here. There's definitely something funky going on there. Well, brain extraction or tissue segmentation would work. And for example, here showing you, okay, that this scan is basically not really nicely usable. And it does the same thing for functional imaging, here also indicating signal fluctuations over time, if there are any spikes or outliers in there that you can then use in your analysis, for example, to get rid of these kind of noisy points, showing you how well registration would work, and many other things. So that's already super cool. If you want to take it to the next step, then pre-processing, we know that there's a lot of things that can go wrong. Everyone does it a bit different. And this Bits app called fMRI Prep, which I guess most of you have heard of by now, is really there to address these things and coming up with a very extensive and comprehensive pre-processing pipeline for both structural and functional data, with the workflow being very easy to specify and adapt. And you also get intuitive output reports and summary statistics. So this is just an example of my report that I have on my machine, showing you a summary of what's happening in there. The pre-processing for anatomical images, very straightforward. You can tell if registrations work, if tissue segmentations work, because you got all of these very informative graphics. You're seeing different noise components that were extracted from your data, how much variance they explain in your data. And then we get the same for basically each and every single function run that we have, again, over time, for global signal, movement parameters, very intelligently what's going on there. Again, get the correlation of these different noise regressors so that we can decide which of those should be included in the statistical analysis, for example. And it gets even crazier. And I did not do this right now. This is actually part of the software. If you use fMRI Prep, it will automatically write the methods part for you. So this is not standardization only in neuroimaging data. This is also standardization in description of analysis, which is what we also need. Because if people, I don't know, describe the same thing with 10 different terms, that doesn't really help us. But if we do these things, you can just copy paste it out of there And you even get all the references that you need to include inside for this description. And that's just very, very neat. The next step would be, of course, statistical analysis, for which there's another bits app called FitLens that basically allows you to run general linear models, so things you would do with SPM, AFNI, or FSL, just using a bits app, where you would also get these very informative output reports in the end, showing you, for example, the design metrics, the correlation of all your regressors regarding the overall signal and variance, the contrasts you computed, and how the contrasts look like. So, and just to tell you, show you what it means is that you're getting super extensive yet easy to run pipeline with basically 5 lines of bash, because you can go from raw data to bits confirmed data using qdconf, then pseudo or anonymize your data set using bitsyndim, and then go further. Once you got that, use quality control using MRIQC, pre-processing using FMI prep, and then statistical analysis using FitLens. Again, these are only 5 lines of bash, basically 5 comments that you need to run to go super reproducibly with amazing pipelines and things that are very hard to come by yourself, from raw data to statistical analysis outputs. And if that's not a super cool, neat thing to do, I don't know what is. And just gonna run over that because of time. There are a lot of other cool bits apps out there that we assemble in the slides. For example, FMI flows, that is an end-to-end pipeline going from pre-processing over statistical analysis, individual and group level, and even allows you to run machine learning analysis if you want to. Then there's FMI denoise if you work with connectivity a lot, that shows you the best denoising strategy for your data. There's CPAC if you want to, like if you work a lot with functional connectivity analysis and these things, it's a bits app that allows you to do basically all the things that you might want to do in there. There's MegaPipe, also focused on connectivity, but also microstructure sensitive to fusion weighted imaging, really targeting multimodal data integration as well. There's MindBoggle if you run structural feature analysis quite a lot, going from everything from volume and surface-based measures, thickness, volume, to funky things like Laplace Beltrami spectra. And if you work with diffusion imaging a lot, as for example QSI prep, and all these things work in the same way. It's a bits app. So you download them from Docker Hub using Docker Pull, and then you send them on your bits data set, and they do the work for you. And all of them produce these super interactive graphical outcomes, standardized outputs, really take everything away that might not be reproducible. Not everything, but most parts. If you want to create your own things in an interactive way, there's a tool called Giraffe Tools, which basically combines a lot of things there, because what you can do there in Giraffe Tools is have a graphical interface where you, with drag and drop, basically can create, for example, any type of pipeline. So if you want to do SPM, estimate models, you can just drag and drop it in and then specify the things that should run, and via drag and drop connecting dots, specify input and output streams, which will, and this automatically writes the entire analysis script in Python for you, and it automatically writes using your Docker the entire Docker file for you with all the software you need, including your workflow you created in there, so that you can run it on your data. So if you don't want to program, you don't have to. There are things out there for this. Comparably, there's an amazing platform called WineLife where you can sign up for free, that hosts data, different codes and apps, and allows you to actually compute things on there. So what you can do is you can upload your data there or reuse an existing data set on WineLife, any open data set really, and then go through the apps. And for example, I don't know what floats your boat. But if you want to do some network analysis, do some network non-models, you can click on that and then basically execute it on your data set or any other data set you want to work with. And it's actually running in the cloud. So you don't have to do it on your own machine. You can all just by clicking using these open resources, do the analysis and just get the results. Which is also true for NeuroScout, which is a platform that does basically the same thing, but for naturalistic imaging. So NeuroScout hosts a large amount of data from naturalistic data sets and allows you to select data sets, different things you want to check out because you have pre-expected features. You can compile an analysis and it automatically brings everything for you together in a Docker image that you can then run and automatically get the output from. So within that, we basically then combine all the things from before sanitization, virtualized environments to get to BitsApp and these adjacent platforms, allowing you to compute things in the cloud and easily compile analysis. And if we go then into results communication, starting with Open Neuro, a thing we've heard before, and I guess most of you are familiar with, this is an amazing website where you can search for basically any type of neuroimaging data, at least the ones that are currently supported, MRI, PET, EEG, MEG, just by keywords. And as I'm doing auditory neuroscience, I can just type auditory, give it a go, and then I see all the different data sets that match that keyword. And because it's all bits data sets, I immediately can understand what's going on, have all the things, and can download things from there. Or of course, as just shown from Adina using Data Lab. So if you want to work with open data, searching for something specific, Open Neuro, at least currently, and I guess what's going on really is the thing that you should have a look at with a couple hundred data sets. And I think by now it's actually over 20,000, it's like 600 data sets, over 20,000 participants, all free for you to use in an understandable, standardized manner. If you want to share and explore things that people already did run, there's Neurowall that allows you to share statistical maps, postulations, and atlases that you can also download and check out, which combines nicely with tools for meta-analysis like NeuroSynth that basically lets you run automated meta-analysis in the cloud. So if you're interested, again, for example, in whatever, I don't know, for example, I'm interested again in auditory, you can just type that in and get the automated meta-analysis results from there. You get all the studies and they're loading, links to it, can download them, can get the statistical maps from them and information, which is also the same for NeuroQuery, which goes further and allows you basically to type in any arbitrary thing. So for example, if I type now in reproducible neuroimaging, that will be matched. Okay, that didn't work out because it was too fancy. Effective choices or something like that will automatically map to control vocabulary, getting you the meta-analysis results with all the different terms in there, all the different analysis, all the different papers with the statistical maps you can download and utilize. And as indicated by GB yesterday, there's this cool new thing called Neurolibra, where people can basically host interactive publications. So not only we want to share a static PDF, but if we want to work with data and show what we've done, these things that allow us to combine descriptions, images, but also code is really the way forward. Because as you can see here, we can interactively explore things, see the code, see how certain figures are produced, and include interactive figures showing nice information. And Neurolibra is currently on the way to make this a streamlined process so that we can all combine data, code, outputs, all in one go and make the best out of it. And it would be really the last part. So if we now have standardized data that we can share, analyze using this virtualized environment, reproducibility, outcomes using bits apps and these other platforms, we can then share our data, our results, also in an interactive manner. Coming back to Repronym, what we should, of course, should do is focus on how these things are done. Not only is this itself is also pretty cool, but we also should be sure that all of these things itself are reproducible. And I think Adina touched in her presentation, there's this cool thing called Repronym containers. That's basically a collection of containerized computation environments, including bits apps, that allow you to basically run an analysis on your data set, tracking everything that happened, the analysis that it run, the outputs, where the outputs came from, how things changed. So in the end, what we of course have is that all the things we do are under version control using Git, GitHub, Data-led, whatever works best for your use case. And if we manage that, then I would say we're on a very, very good track regarding reproducibility. And this was basically just a super, super quick run. Sorry again for the time, showing you how these things can and already are integrated with one another to achieve more reproducible neuroimaging. And all of these tools are free to use for you at any point in time. They all have fantastic documentation out there. They all have tutorials out there, YouTube videos that showcase how these things are done. The important part really is that you decide that you want to use it and actually have the opportunity to do so, have the means. And as we heard yesterday, sure, sometimes you can just don't run Docker images because your architecture doesn't support it, but there are other ways you can explore to make this happen. So even though if you cannot maybe do everything, you can at least do all the things that are able for you, right, and possible. And the last piece of it, I only included a few more slides and information on other helpful resources related adjacent to us, with Neurostars being this amazing open discussion board, getting all the information and help that you might want. The BrainHack organization and initiatives basically bring together people from all over the world for collaborative brain hacking, so working on open source code related to neuroimaging. There are cool training and teaching initiatives you should definitely check out, like Neuro Academy, the Montreal BrainHack School, Neuromatch Academy. Most of them are free, and if they're not free, they have support, financial support for individuals from underrepresented and marginalized groups. So all of the materials are also open out there with videos. Definitely make sure to check those out as well. And there are many other very important initiatives out there that we don't have the time to touch on, unfortunately, but are things you should definitely know about because they concern all of us, starting with the Women in Neuroscience repository, where women in neuroscience can create a profile so they can collaborate, network, and are also findable for people organizing workshops, events, and whatnot. There's the Open Science interest group of OHBM and the Student Postdoc interest group of OHBM, bringing these two forward in the realm of early career researchers. We have the Queer in Neuro initiative that is currently, I think, in the formation. So if that's of interest to you, there's a Google form you can sign up for. And there's the Black Neuro community that organizes a lot of very, very great events a couple of times throughout the year that you should also definitely be aware of and follow. Other fair initiatives and support include the Project Tier and the Turing Way, things you already also heard a couple of times during this workshop. And there's also more general things out there that showcase you how you can use open and reproducible tools along the different stages of your workflow and the tools thereof. For example, the Open Science Rainbow, which is copy-pasted in here, showing you from searching, starting things, to basically putting everything out there. What can you do to make it more open and reproducible? And with that super quick run through, I'm done. Ending directly over into the Q&A. Basically, just wanted to tell you again that we have this website where all of these things will be hosted, of course, again, and way more, because if you go in there, we have the different Repronym modules, for example, fair data, how basically you can use different tools to achieve more reproducibility. We have different showcases. That's called the How Would Repronym Do That series, where we show how you can make certain parts or things in the research workflow more reproducible with like super lengthy, detailed tutorials to make it as easy for everyone as to follow. And we have, of course, the teaching focus, the super big Repronym. And when you go to the teaching aspects of our website, you actually see that we have this organized in different modules, from introductions, basics, fair data, processing, and statistics, with each being its own little course that you can check out, all free online for you, available at any time. And we have this cool, what we would call a good pyramid scheme. It's called Train to Trainer program. The thing in Adina already mentioned, it's the fellowship, the Repronym fellowship, where you can apply for very short application, and then for 1 year, you will be a Repronym fellow working with us together on reproducible neuroimaging, with the aim of you then training other people in your home institute and lab for the same things. So that's why we call it a good pyramid scheme. And as Dave mentioned, this year just ended in terms of the application round, but there will be a next one next year. Applications should open up, I think, in the fall. And we also have what we would call Repronym Plus courses and things. For example, we have the ABCD Repronym course, where we apply all the things Repronym to the amazing ABCD data set, showing you how this can be done, or how you can work with this data set, analyze in a reproducible manner. And also, I think, correct me if I'm wrong, Dave, this year added for the first time an extra course specifically for AI and machine learning reproducible analysis for ABCD. And with that, sorry once more for all the timing issues and all the lot of content. We really tried to pull it down. But ideally, each and every topic that we presented to you would be its own 1-day workshop or 2-day or 1-week workshop, what have you. But again, our focus or aim was to showcase you all the things that are there, what you can do, so that you have at least, and if, I know it's still a lot, but please at a later point in time, go revisit these things and see what you can do and the things that are important to you and that work out and how you can utilize them. We would like, of course, to thank you very much for the attention and participation. Again, with you being like here and showing up, you already showed that this is of interest to you, which we find fantastic. Thank you for. And please reach out to us with any questions you might have now, later, email. We are on the Mattermost channels, Twitter. Just drop us a message. We're always happy to receive those.